Okay then, guys and girls, what have we got here today? It's not a Makita, something different today. It's a Festool CS70 EB Precisio. It's a German brand, but that doesn't sound like a German word. It sounds more Italian. So what's the problem with this? The customer says that it sounds like it speeds up and slows down. So let's start it up. There we go. It doesn't sound very good, does it? It does sound like it's speeding up and slowing down, but it also sounds like there's some kind of sparking sounds coming from where the brushes meet the commutator. I've seen on these before that they burn the brush holders, so it could be that. It could also be that the carbon brushes are down to the end. I know also on these they had a problem with some of the circuit boards. It could also be the stator. So basically I need to take it apart and hope that I find something clear that shows me what the problem is. Right then, I'm going to start by flipping it over. Don't forget to unplug it unless you want a little tickle from the 240. Right then, I'm going to start by removing all of these screws that hold this plastic on here. So you use a T15 for this. This one's got a speed adjuster. They don't all have that. Okay, let's have a closer look here then. So, this is the circuit board that has had some problems before. If it's the older version, the older part number, then it could need changing. But if it's the newer part number, then it's probably not that. And then this thing here is the brush holder. So I don't know if you can see down there. You can just see these are the springs that push the brushes in onto the commutator. And you can't really pull this out very far without removing the brush holder. So the first thing I'm going to do is try to remove the brush holder. And in order to do that, I need to, here's the spring, and the spring pushes on the back of the brushes. So I need to try to remove the spring from the back of the brush. Oh, I can't speak. The back of the brush. And I also need it to stay down there as well. Kind of need two hands for this. So I'm going to use the pick and the flathead screwdriver, small flathead screwdriver. I'm going to pull the spring out with the pick and push the brush out at the same time with the screwdriver, hopefully. I could use a bit of light. That's one. And the second one I didn't need to pull fully out, I could just pull the spring back. And you can see that this then just slides out of here. And now you can see what I mean. This was the spring, and it pushes the brushes in. And you can see that this brush is out because that's the one I hooked over the edge here. And this one is in. But looking at this brush holder, I don't see anything seriously wrong. I've seen these burnt out before, and they're normally a lot worse. So this is not melted at all. And the brushes are long, so it's not a problem with the brushes. So now we're down to the circuit board or the motor. Let's pull the circuit board out. Have a look at the part number. I'll check that on the computer later, see if it's the old one or the new one. But then we can have a look on the top surface here. See if we can see anything burnt. Obviously, look at the capacitors, see if they're bulging. They're not bulging at all. Look at some of the chips if you can. See if they look burnt, they don't. They put a lot of this silicone on so you can't see everything. But I don't see anything obviously wrong with this. Which means the next thing to check is the motor. In order to check the motor, we need to tilt this whole thing tilts, because obviously sometimes you want the blade to be at an angle. So you want to tilt it so you can get access to the screws on the front. Start pulling the screws off and the plastic. This one's nice to keep the screws in. Okay, to remove this belt and this pulley, I like to just turn it backwards and forwards, pulling it upwards, and then do the same with the belt at the same time, just forwards and backwards and upwards. There we go, it should come off like that. We can inspect the belt. Just fold it over a little bit and see if there's any cracks on it. Looks in good condition to me. You can see on the underside of here that this inner section of the pulley has got splines that meet down here. And so this turns freely until it's all the way down. Then you can feel that it turns. Here it turns the cutting blade, and here it spins freely. This one here is quite deep, so you need a screwdriver for this one. I can't do it with the impact. Okay, to gain access to the motor, we don't need to take off this lower belt. Okay, now we see the top of the motor. This is the fan here. You can see it spins. Feel how it spins. Spins really nice. Doesn't feel like any bearings are damaged at all. So, let's take it off. There we go, that was the motor sliding out. Can have a look at this now. Just going to check the commutator for damage. I can't see that the windings are particularly dark or burnt. Maybe a little dark, but that could also be the varnish. You never know. But you can see here, looks a little bit strange. On the commutator here, I can see a little crack in the varnish, and also here looks a bit strange. Looks a bit darker. Looks like something maybe has melted, maybe. See that dark black patch there? So it could be that, but it's nothing, it's nothing like really obvious, unfortunately. And then we'll have a quick look in here, see if we can see any burnt wires. And there we can see the stator winding. I guess this is a universal motor because it's 220 and it's got brushes. No, I don't see anything burnt in there. Nothing melted in the end, so that's a good sign. So that leaves us with just the circuit board or the motor, and we have seen a little the rotor, and we have seen a little bit of damage on this, so I'll try and measure it with a multimeter and we'll see if we find anything. Okay, first thing I'm going to do is give the commutator a little clean with this pad, abrasive pad. Okay, now I can measure the resistance of the adjacent commutator segments. Can you see that? I can see it. Okay, measuring the segment to segment resistance didn't really tell me that much. They were all basically about 0. Nothing was shorted to either another coil or to the shaft itself. The circuit board part number was the new type, so the only clue I've got to go on is the appearance of the commutator. I don't see any obvious physical signs of damage like raised bars or rounded bars, so it could be a build-up of carbon in between the segments. But as the commutator did look a bit strange, and I've taken it apart now, I'm going to go ahead and change the rotor. And I think that's what you've got to look forward to in part 2. Ideally, I'd have a growler to test the armature. I've been thinking about trying to make one for a while. If you think that's a good idea, something you're interested in seeing, let me know in the comments and subscribe. Cheers. See you next time.